Hello class. So we're gonna start today by going over the answers to yesterday's homework or last week's homework. So the first question is we want to write a function called fizzbuzz that takes in a list of numbers and will go through each of the numbers and will apply a certain algorithm. So that if the number is divisible by 3, we will print out fizz. If the number is divisible by 5, we'll print out buzz. And if the number is divisible by 3 and 5, we'll print out fizzbuzz. And otherwise, we'll just print out the number. Okay, so that seems pretty simple. So what we need to do is we have to write a for loop on all the input numbers. That way we can execute a block of code for each of the input. So we had the condition where if the number is divisible by 3, then we'll print out fizz, and then else if number is divisible by 5, we'll print out buzz, and then else if the number is divisible by 5 and number is divisible by 3, we'll print out fizzbuzz. And otherwise we'll just print out the number. So since this is Python 2, I have to wrap these print functions or prints in. I have to call usePrint as a function. So this looks correct, right? But actually this is not correct, because if we think of the number 15, and as the number 15 goes into this block of statements, we'll see that 15 is divisible by 3, so we'll end up just printing fizz. And since this is a if else or if else statement, only one of these will get executed. So what we really want is for 15, for this to get executed, line number 8. So what we can do is we can actually move this statement in front of the line, so that would get the condition here would get checked first. And another thing that we can do to simplify the problem is that if a number is divisible by 5 and the number is divisible by 3, that's the same thing as saying a number is divisible by 15. So we can make it a little bit simpler like this. And one more thing that we can do is that we can actually move this into a helper function, so that this fizzbuzz function is not so large. But that's not too important, so I will skip that. Next, we want to write a function that checks if two numbers sum up to 0. So in order to group two numbers together, we have to do a double for loop. So it would look something like this. So we can call it number x in numbers for number y in numbers. We can do if number x plus number y is equal to 0, then we found our pair. And at the very end, if we went through every pair of x and y and we have not found a result, we just return false. This should be returned true. So this looks correct. However, this is not absolutely correct, because if numbers is, let's see, if numbers is just an a list with just 0, then what will end up happening is x will be 0 in the first loop, y would be 0 as well, and then we do 0 plus 0 is equal to 0. That's true. But really, our list only has one value, and it's 0. So this cannot return true, because there do not exist two numbers that return, or two numbers that add up to 0. There's only one number that it added by itself returns 0. So what we need to check is we need to check if the index of the numbers are different. That way, we can know that the numbers are coming from different positions in the list. Therefore, they're distinct numbers. So one thing that we should do instead is that we should loop over the indices rather than the actual numbers. So in order to do that, we use I for an index, and we have to change this to a range of the length of numbers. And then in order to get the number x and number y, we can get it from the numbers array, and we get the I index. And we can do the same thing for j. Okay, so this is updated, and this will work now, and this will return false as expected. But one more thing that we can do to simplify this problem is that there's a special function called Enumerate, which takes in a iterable, and it'll generate another iterable, and then that iterable it's going to have pairs of numbers, or pairs of values. The first value is the index, and the second value is the actual value at that location. So we can do something like this. And then we can just check if x is equal to y is equal to 0, and this would work too. And it's a bit cleaner than our original solution, so that's good. Okay, in this next one, we have a number that's missing, and it's between 1 and 5. So our input array will be 4 numbers, and we just need to see which one's missing. So what we can do is we can do a for loop on the list of numbers, right? Actually, we don't want to do a for loop in the list of numbers. We want to do a for loop from the range of 1, 6. Remember that the 6's range is not inclusive of the ending number, so 6. This range will be equivalent to 1, 2, 3, 4, 5. So if this number in this range is not in numbers, then we know that this is missing. Otherwise, there's no other scenario, because there's, based on the specifications, there's going to be one missing number. Okay. Now we can start on today's material, and most of today will be review and then writing functions. So let's start with the review. So one of the basic data types is are numbers, and then there are two types of numbers: integers and floats. So integers are numbers that are whole numbers, like 1, 2, 5, 10, that kind of stuff. And floats are numbers that have decimals in them, and that way you can do division, and then you can get like 1 divided by 2 is 0.5. So with these numbers, you can apply a lot of operations with them. You can add two numbers together, you can subtract two numbers, you can multiply, you can divide two numbers, you can take the negative of one number, you can take the remainder of one number divided by another number. So if you have 9 remainder 2, that would be 1. You can raise one number to another number. For example, 3 squared would be 3 star 2. And if you have an expression, you can prioritize that expression. Let me make it this so it's more obvious that this is not just one variable, but it could have a whole expression in there. Another thing that you can do with numbers is you can compare them. You can see if a number is greater than another number, a number is less than another number. With all these comparison operators, you're going to get a Boolean back. So a Boolean would be true or false. There are some built-in functions in Python that will help you with help you solve some problem that you may have. And Boolean operators, or I guess with Boolean objects, you can apply Boolean logic with Boolean operators. So you can do an AND clause, which will test that both of the inputs are true. An OR clause would check that at least one input is true. An XOR clause checks if exactly one is true, but not both. A NOT clause would check if the input is false. And if the input is true, it would just convert into a false. So it just does the opposite. And you can also use parentheses to prioritize certain expressions. But if you do not use parentheses, then the order of operations after that is negation goes next, and then ands have precedence over ors. So here's a truth table of ands, ors, and XORs. So ands will only be true if both x and y are true. So we only see true here. And x or y is true if at least one of x is true. So in these last three scenarios, at least one of the inputs is true. Therefore, you see true here, but you see false here because both inputs are false. For XOR, we need exactly one true, and it's only the case for the two in the middle. Great. So next we have strings. Strings just represent a list of text, and we can construct strings with single quotes or double quotes or even triple quotes. And depending on what your scenario you're working on, you would use a specific quoting system. So with strings, you can get a character at that index. So you can do bracket 1 right after a string, and it'll get you the character at this index. And one important thing to remember is that the output of this is the same data type as the input. So if hello is a string and you get the index of 1, the output is also a string of length 1. In other languages, the output it would be a different type, namely a character. But for Python, the output is still a string. So if you wanted to, you can still do all the operations that you want on this this output as if it were another string. You can also do a negative index. Negative index works by counting backwards. So the first number backwards is -1, second number backwards is -2, and so on. You can get the length of a string. You can lowercase string. You can uppercase string. One thing to note is that this lower function will not, if you have a string in a variable and you call .lower on that string, it will not update that string. It will return a new string. And if you want to save that result, you have to reassign it to the original variable. You can add two strings together. You can convert a number to a string. You can check for existence in a string. And let's go on with lists. So lists is another type of data type that contains multiple values. And the values that it contains could be any data type. It could be all lists, all numbers, or even a mixture of lists and numbers. So similar to strings, you can get the index of at a position, or you can get the value at a certain position by indexing. So this will get you the list at the value at position 1. So in programming, we count starting with 0. So A is 0, B is 1. So that's why we get B here. We can also do negative indexing. So we count backwards. So this is C. We get C here. We can get the length of the list. We can use a function called append, which will add a value at the end of the list. We can update a list at a value at a certain position for a list. So if you have A, B, C, and we set the first index to D, then the result will become A, D, C. The one important thing to note is that strings and lists are similar, except for because they're both a collection of items, if you will. But for strings, you actually cannot do this operation. The reason for that is strings are immutable and cannot be updated. So you can use a function called pop, which would remove the last element, and then it will also return that last element. So if we print the pop, you will get the E because it's the last element, and then when you print the list again, it will be the same list without the E. And then you can also use a function called remove, which will remove a value from your list. So in this case, I'm removing B from my list, and the result is A, C, D, E without the B. If you have multiple B's in your list, what will happen is it will just remove the first occurrence. You can also convert a string or any iterable type into a list. So if you pass in hello, it will just give you hello, but all in individual characters in a list. You can check if a value is in the list or not, and you can also split a string into a list separated by or given a delimiter. In this case, we have a space as a delimiter, so this will split into words. Okay, and then the last data type for this class is dictionaries. Dictionaries hold a key value pair, and you can construct a dictionary with curly braces. And one thing that you can do with dictionaries is you can add an element to dictionary. So in this case, I'm adding Kevin, and I'm mapping the value for Kevin to be 25. And after we print our dictionary, we will have Adam and Eve from our construction, and we have Kevin right here. There should not be a comma there. Oops. There should not be a comma there. Okay, so we can also update a value in our dictionary. So we start with Adam and Eve, and then we'll set Adam to 24. So what will end up happening is that the value for Adam will be updated. It's not going to create two entries for Adam, but it's going to update the existing value for Adam. And the syntax for updating is the exact same as syntax for adding an element. The only difference is that the dictionary did not have that element before. So another thing that we can do is, if we know the key of an element, we can access the value. We can retrieve the value. So in this case, we have a dictionary is just Adam and Eve, and if we do age by name Adam, we get 23 back. We can also remove a key value pair. So we have Adam and Eve as a dictionary. We remove Eve, and the output will be the dictionary without the key value pair for our Eve. We can also check if a key exists in the dictionary. So if we have Adam and Eve, we check if Bob is in the dictionary. That's false. We can check if Eve is in the dictionary. That's true. Note that this only works for keys, not values. So if you check something like prints 23 is in the dictionary, that's false, even though 23 is a key, it's a value in the dictionary. We can get the number of key value pairs with the length function, and we can get all the keys of a dictionary. We can get all the values of the dictionary. One thing to keep in mind is that the dictionaries have no ordering. So in this scenario, we might see Eve before Adam, just because unlike lists, dictionaries are not ordered. Oh wait, so there's one more data type, which is range, and range can take in multiple types or multiple arguments, or sorry, it can come in multiple shapes. So one shape it can come in as a single argument. So when you pass in a single argument, it's going to assume that we want to start with 0, and then it's going to go all the way to the first argument's value. So if you put in something like 5, you start with 0 all the way up to 5, but not including 5. It's important to know that in ranges, the ending number is not inclusive, but the beginning number is inclusive. So that's why we don't have 5, but we do have 0. When we pass in two arguments, the first argument is starting value, last argument is ending value. So in this case, we start with 3, we go all the way up to 10, but we do not include 10. So that's why this stops at 9. And another scenario is 3 argument scenario. So the first parameter is start, second parameter is end, and the third parameter is skip. So we start with 3, we skip 2 to 5, we skip 2 to 7, we skip 2 to 9, we skip 2 to 11, but since 11 is at least equal to 10, we do not include 11. We can also do something similar with a negative third value. So our increment is negative. So that means we're going to start at 10. We're going to go all the way to 3, counting backwards by 1. So this goes from 10 all the way to 3, but remember, it does not include 3 because 3 is the ending number. And we have tools that will allow us to help build larger functions or larger programs. So one of the first things that we have in our tool belt are functions, and functions just allow us to create a block of code that we can repeatedly call in order to get an answer to a result. So the way the functions work is you type in def to define a function, you specify a function name, and then you specify the number of inputs, or you specify the inputs of that function. So a function can have 0 inputs, or it can have 100 inputs. But usually functions have a reasonable number of inputs, like at most 5. And then you have your statement bodies in your function. It's important that we indent all of the code within this body with 2 spaces, so that the parser will know that those lines are within the function rather than being outside the function. So the next thing that we have are if-else statements. So if you just have an if statement by itself, what will happen is there's a condition, and if that condition is true, we will execute all of the code in the if block, so in this group. Another thing we can do is we can have an if-else block. So the difference between this is that there's going to be 2 blocks that might be executed. So based on the condition 1, if that's true, we will execute group 1, but otherwise we'll execute group 2. And then we also have a concept called else if, and for else ifs, they have to occur in between ifs and else. So the way the way that if and else if work together is that when you have them, the first if condition that is true, then we will execute the body of that if condition. For example, if condition 1 is true, we'll execute this group 1. But let's say condition 1 and condition 2 is true, we'll still just only execute group 1 because the condition 1 occurs first from line to line. And if no conditions are true, we'll end up executing the else group. It's important to know that only one group will be executed. So another thing that we can do is we can loop over a iterable, something that we can iterate over, and assign a loop variable for that value, and then execute a arbitrary piece of code for every item in that value. So here are a couple examples. We can loop over lists. I guess these are the different collections that we can loop over. We can loop over a list and print all the values of the list. We can do the same thing for a string. We can do the same thing for a range. We can also do the same thing for a dictionary. When we do it in the dictionary, we will loop over the keys. And one thing to note is that dictionaries, again, do not have an ordering. So you may see Bob before you see Alice. Even though, as it's written out, you see Alice first before Bob. So, yeah. So another thing that we have is we have while loops. And the way while loops is that there's one condition, and while this condition is true, we will execute the body of the while loop. It's important that you make sure that whatever you do not have an infinite loop. So if you are checking if a number is greater than 0 in here, you probably want to modify the number within this while loop so that eventually the loop will exit out. Okay, we're going to start some exercises. As I go through these, please pause the video if you want to give them a try. So square, this is to square a function, we just multiply the number by itself. So we can just do number times number. So this actually won't work exactly because when it doesn't have any return statements. So we also have to put a return statement here. But it's also what I see a lot of people do is that instead of returning, they would type in print. And the one problem with this is that even though when you call square, you will see a 9 back as expected, you can't really apply additional operations on this. For example, what if you want to square a number and you add 3 to it? This will actually return an error. So what you really want to make sure is that you return functions, and then the caller of your function could decide to print the result if they want, or do whatever they want with the result. So this next function is called square all, and we want to square all the numbers. So one thing that we can do is we just have a for loop, and then in the for loop we get the square of that number, but then we have to save the result somewhere. So if we create a list here, we can add that to the we can add the result into our result list, and then we can eventually return this result. But the one problem is that if we put this initialization within the for loop, this result variable will get reset every time we go this for loop. So we have to create it outside of the for loop. And one thing we can improve on is that this is the exact same as a square function above, and if we want to reduce the amount of duplicated code, we can use the square function above. Okay, so this is one way of doing it. Another way of doing it is using a thing called list comprehension, where we we started with open bracket, close bracket. This looks like a list, but within the list, within these brackets, it's not going to be values. It's going to be a expression, a list comprehension expression. So it looks something like this: for number times number, or sorry, square of number for number in numbers. So this is a bit fancy, but this also works. So another thing we can do is there's a function called map, and what it does is it takes in a function and takes in a list. So what it will do is it will apply that same function to all of the values in the list. So we can call map square of the original numbers. This also works. It's also a bit fancy. So if you don't understand these two, that's okay. the important part is to understand how to use the basic for loops. All right, so there's this function that just returns AM or PM based on the time. So if it's very simple, we can just check using if statement. If hour is less than 12, return AM. If hour is greater than, or otherwise it's PM. Okay, so this next function that we are working on is a function that determines if a time is AM or PM, and we can easily know if a time is AM if it's less than 11 or equal to 11, and otherwise it's PM because 12 is the first PM time. So we can do this with the if statement. We can do if hour is less than or equal to 11, we want to return AM, otherwise we want to return PM. And 2 spaces after this, and 2 spaces after this, and that's it. So that was pretty simple. We can look at the next one, which is a little bit more difficult because we have to also include the time. So we can still have those 2 if cases. So we can check if it's AM or PM. So if hour is less than or equal to, I guess we can say that the second part of the result, which we can call it second part, is equal to our first function, spell number of hour. And then the first part would be, I guess, simply we can just, if the number is greater than 12, then we can subtract 12 from that number to get the AM version. For example, if the number is 13, we subtract 12, then it's 1 PM. Otherwise, we leave the number alone. So if number is greater than 12, then we can say, if hour is greater than 12, we can say hour is equal to hour minus 12. So one important thing is that, I guess, if hour is 12, we don't want to subtract 12 from it because then that'll give us 0 o'clock, whereas it should be 12 PM. Okay, so this looks right. So we can just return the result of hour and then the second part. And this hour is not is the new hour, which is good. One thing that we have to do is that this is a number, integer specifically. The second part is a string. So in order to add these together, we have to convert the number into a string. Right. So that looks good. So my all, it will return true if for every entry the value is true. So for example, with the first part, all the values are true, so it's true. Second part, there exist multiple values that are not true. There exists at least one that's not true, so this is false. And here, are all the values true? Yes, even though there are no values, they're all true. So the last example is also true. So one way of doing this is we can loop over the entries to find a false, and if there exists a false, then we can say that the result is false. And then after we finish looping over all the entries, we can say that the result is true. So we can do for entry and entries. Oops. If entry is false, we want to then return false, and otherwise we want to return true at the very end. And then, so this is good. Another way of doing this is just using a not, because not false, if entry is false, then not false would become true, and then we will return false here. So that would be equivalent. Okay, great. So any is similar. I'm not going to do this because this is going to be part of the homework. Next is reverse. Reverse is also part of the homework, and I guess there's multiple ways of doing this, but I'll leave it up to you to try to figure out. So remove zeros is, let's see, remove zeros is not part of the homework, or no, yeah, it's not part of the homework, so I can do this. So what we want to do, the hint says we want to use a while loop, and let's try to not use a while loop and see what happens. So if we use a for loop for entry in entries, and we can say if entry is equal to 0, we can just remove this entries. We can remove 0 from it, and then we just want to return the entries at the very end. So let's type this in Python and see what happens. So there's Python. So remove zeros of one, 0, 2, 3, 4, 0, 4. And then let's see what happens. Whoops. Type it in wrong. Yeah, I have one extra E. I guess I defined incorrectly. Okay, this actually works perfectly fine. So another way of doing this is that we can use a while loop, and we can detect if while there exists a 0 in the list, we can remove it from the list. So we can do while 0 in entries, remove entries. So let's test this out as well. And it works just fine. Great. So is palindrome. The way we can do this is we can have we can loop over, and we can say that we can loop over from start to end by index, and we can get the negative index by using the length of the string minus the original index. The way this works is, like, let's say the length is 1, for this example it's 7. If the index is 0 for R, then the last index is, actually we can do this even easier. So we can use negative indexing to make this easier. So if the index is 0, then from counting backwards it's -1. If the index is 1, counting backwards is -2. So the way we can do this is we can add 1 to the value and negate the whole result. So give examples. This is 0, then this is 1, then 1, -1, or oops, -1, -2, okay, 0, 1, -1, -2, 2, and -3. So, and then in the middle it's 3 or -4. So this is R, A, 0 is R, 1 is A, 2 is C, E is E is 3 or -4, and then -3 is C, -2 is A, and -1 is R. So to given a certain index, to get its complement is you subtract, or sorry, you add 1, and then you negate the whole value. So 0 plus 1, and you negate the whole thing, that's -1. From A 1 plus 1, negate the whole thing, that's +2. And for 3 plus 1 is 4, negate the whole thing is -4. Let's see if this works from backwards. So -2 plus 1 is 2, -2, negate the whole thing is +2. So this even works with negative numbers. So this is perfect. So let's do for I in range length of the word. So its complement j should be equal 1 plus I, and then we want to negate the whole thing. And then if the letter at position I does not equal to the letter at position j, then we know that this is not a palindrome. Otherwise, we want to return true. So let's see if this works. Whoops. There's some indentation error. Let's see. This looks fine to me though. Return true. Oh, I'm using double equals here where not equals is just not equals. Okay, great. So let's see if race car is a palindrome. Yep, it is. And then let's see if beep boop is a palindrome. And it's not. Great, so this works. So factorial we went over in class, but let me do it again. There's basically 3 ways of doing this. We can use a for loop, and we want to loop from 1 to 5, or sorry, 1 to n, right? Where n is the max number, and then we want to multiply all the numbers within that range. So we do this by doing result times number, and we set that to result. And we initialize result with 1. We can't initialize it with 0 because if we keep on multiplying all the results, it will just end up being 0. We can do the similar thing using a while loop and increment n down until it's 0. Or we can solve this recursively where we can say in the base case n is equal to 1, and otherwise the result is n times factorial times n minus 1. So if n was 5, this would be 5 times factorial of 4. And factorial of 4 is equal to 4 times factorial of 3. And factorial of 3 is equal to 3 times factorial of 2. And 2 is equal to 2 times factorial of 1. And then 1 is just, factorial of 1 is just 1 because it's a base case. And this whole result gets pushed back to the initial caller, and the whole thing is multiplied together to get the right answer. Great. So Fibonacci is something similar. So the way we want to work with recursive functions is that we define a base case, and the base case for Fibonacci is that the first 2 numbers are 0 and 1, and the next numbers are the numbers, one number the previous number plus the previous number. So let's say if n is equal to 0, then we can just return 0 because that's one of the base cases. If n is equal to 1, we want to return 1. Otherwise, we want to return Fibonacci of n minus 1. plus Fibonacci of n minus 2. Great. So, this next function is called isPrime, and the way this works is that a number is prime if it's only divisible by itself and 1. And the way we can do this is we can start from looking over the range between 2 up to the number, and if any of those numbers divides evenly with the original number, then the original number is not prime. And of course, we have to consider what if the number is 1, and I believe in mathematics that 1 is considered prime. So I can do if number is equal to 1, just return true. Otherwise, we can do for n in range of 2, comma, the number, not including the number, and not including 1, because 1 will divide evenly with all numbers. So we can do if number is divisible by n, then this is not prime. Those one return true. Great. Alright, so that's great. So this next one is part of your homework, so I will leave it out. This next one is not part of your homework, but it's very similar. But I will just do this. So this requires a bit of thinking, or this requires multiple parts that we have to put together. So one thing that we have to do is we for sure have to do an operation on all of the numbers. So we want to use a for loop, and let's think about what we have to do. So we have to for each number we have to it may or may not be in the dictionary. So add the number in the dictionary if it does not exist. Increment the number in the dictionary if it increment the value of the number in the dictionary if it already exists. Great. So add the number in the dictionary if it does not exist with the value of 1, because we've just encountered one of the values. Okay, so that seems simple enough. How do we check if a number is in the dictionary? We can use the in operator. So if number is in, I guess we have to create a dictionary first, and we have to create it outside the for loop, otherwise the dictionary would keep being reset. So if a number is in the results, I guess if the number is not in the result, we can do results of number is equal to 1. Otherwise, the number is in the results, so we have to increment that number. So we have to retrieve the original number by doing this. We want to add 1 to it, and we want to set it to a variable like new number, and then we want to update the value at this. We want to update the value with a new number, the new count, if you will. I'll just call this new count. So this looks good, and then we can just return a result. So one thing that we could do, instead of making this 2 lines, 2 statements, we can just do a shorthand, just make 1 statement. And one thing that we can further simplify is that this is just adding 1 to this result, so we can just convert it to a plus equal sign. So that works as well. So let's just check this out just to make sure it works. So count numbers of 1, 1, 2, 1, 4. Yep, that looks correct. Great. Okay. So this next part we will just check if a list has duplicates. So see, how can we do this? So what we can do is we can call count numbers, and what this will give us is the count for each of the numbers, and then we can loop over those counts and see if any of the counts is greater than 1. Okay, so we just call counts is equal to count numbers of numbers, and then for number in counts, remember that this is a dictionary mapping a number to its actual count. So number is a number. So I guess we can just loop over the values. So for count in the values of counts dictionary, if count is greater than 1, then we know that there's a duplicate. Otherwise, we can return false. Great. So we already went over this map function, I believe. Otherwise, this would not be written. So select is another function that is considered higher order function, and it's higher order because one of its inputs is a function. So select is a function that takes in a function and will filter out a list based on the result of this function. So how do we do this? It's similar to map, but we are not applying a function and returning the result. We're applying a function to determine if we should keep a value in a list or not. So we can do something similar. We create a result. We loop over the entries in the list, and then we can conditionally add that element in the result. So if entry, if the function called on entry is true, the result of it is true, then we'll append it to this list. Otherwise, we don't do anything and we just return the result at the very end. Alright, great. That's basically it.